Okay, welcome. This is lesson 6-9, and as you can see, it is a problem-solving lesson, although this one is really just word problems that come from our chapter. And there is a slight difference with these word problems. We're going to be working a little bit backwards. And what we're going to be doing is we're going to be doing percent proportion type problems, but we're going to do them using equations. So the strategy that we're going to be talking about is writing an equation. You're going to read the word problem, turn it into an equation, and then solve it. Okay, so that's it. So let's take a look at a sample problem here, and I'll show you exactly what we mean. All right, so suppose that a bike, sorry, that didn't come out very good. Here, I'll make it a capital B. Suppose a bike is on sale for 30% off, and so the price that you still have to pay after the sale, after the discount, is $140. Well, what was the original price? Okay, and the way we're going to solve this, first we've got to look at the percent. If I save 30% off of something, first you got to have to think about, okay, how much am I actually still paying? What percent of the original price am I left paying? And the answer is I'm paying 70%, okay, of the price that was originally charged. And it's telling me in this equation that I pay $140. So that almost exactly is the equation we're going to use. Okay, and so we talked about this. One of the ways to do percent of a number, the second way we talked about was to take the percent and change it into a decimal. So we're going to do that here. We're going to make 70% 0.70. Of in mathematics always means times. P is the price. That's what we're looking for. And it equals 140. Okay. Now to solve this equation, what I have to do is get P by itself. So I'm multiplying by 0.70. So the opposite of that would be to divide by 0.70. Now when you divide by something smaller than 1, it actually has the effect of making things bigger. Because you think about how many times does 0.7 go into, well, let's say 7. It goes in 10 times. Okay, so when I divide 140 by 0.7, I'm going to cheat and use a calculator here. What's going to happen is it's going to get a lot bigger. And 140 divided by 0.7 should be 200. Yes, it is. There we go. All right, and so I get a price. The original price is $200. Now, if I don't feel good about that answer, I could always stop and go back and say, okay, well, let's say I started and went the other direction. If the bike was $200 and I put 30% off, let's figure out what the discount would be. Well, 30% of 200 would be 60, and sure enough, that would be the discount. And if I subtract that, of course, I get back to the price in the problem, $140. So it checks. We just checked it. Okay. So what do you need to get out of this? Well, here's the strategy. You first of all need to read the word problems and figure out how to change them into an equation. And a lot of them are going to involve kind of working a percent backwards. So we're going to have to be thinking about adding or subtracting percents to or from 100. Okay. In addition to that, we're going to set up an equation, and we're going to solve it using a little bit of one-step equation solving algebra that we've learned earlier in the year. All right. So that's it. That's the problem-solving strategy. So let's try another problem that's very similar to that. This time, a little bit uglier numbers. Let's suppose that we have a jacket that's on sale, and it's on sale for a sale price of $29.97. And that's after a 25% discount. All right, so now let's work backwards and find out what the original price was before the discount. So once again, if I have 25% discount or 25% off, I'm paying 75%. Let me show you how to set it up this time as a proportion. So 75 over 100, that's this is the amount that we're paying out of the total. Okay, and we already know the discounted amount is $29.97, and again, that's the one that corresponds with the 75 because that's the reduced price, and we're looking for the original price. So there it is as a proportion. Okay, you could have also solved this as 0.75 times P equals $29.97 like we did on the first one. Divide both sides by 0.75, and of course if you have a calculator, that'll give you the answer right there. If you don't have a calculator, you might be a little better off going ahead and cross multiplying. You get 75x. 100 times $29.97 is just going to move the decimal out to the right. Divide both sides by 75. And once again, just like we talked about the other day, I either can divide 2,997 by 75, or I can divide 29.97 by 75. And if you recall decimal division from the beginning of the year, all I'm going to do at the beginning of this division problem is move the decimals to the right. So these are really the exact same problem. Now to finish this up, if I take 29.97 and I divide by 75, again I'm dividing by, especially if you look over at this one here, I'm dividing by a decimal, so I should get an answer a little bit bigger than I started with, and sure enough I get $39.96. Okay, and I'm not going to go through the full check on this one, but that's about $40. And so if something is $40 and I take 25% off, I'm taking a quarter of the price off. I'm basically taking $10 off. So I ought to get something really close to $30. And sure enough, I did. All right, let's do one more example that doesn't involve money.
Says, hi, Mr. Gunn.
All right, let's try one that doesn't involve money. Suppose that we have a town, and this time, let's say it's increased, not a discount. And so the town's population went up by 15%, maybe over a decade or over a period of time. And the population now, increased population, the new population, is 75,000. So the question is, what was the population before? Okay? So again, let's think about this 15% increase. Well, if I started with the town's population and I go up by 15%, well, all the people that used to live there still live there, and then 15% more people have moved in. So the percent I'm going to use is 100 plus 15, or 115%. And again, I like setting these up as proportions, so let's do 115 over 100. Okay, and 75,000, let's think about that. Does that go with the 100 as the original total, or is that the new population? And I think very quickly you'll see that that's the new population. So it goes up here on top. And the original population goes down here. All right, so solve this by cross-multiplying. And you're going to get 115 times x is equal to 100.75,000. Divide both sides by 115. Okay, do a little fruit ninja there. You get x equals. All right, now let's do some canceling here. I want to do this by hand without a calculator. So let's take a 5 out. 5 goes into 120 times. We've seen that lots lately. And it goes into 115, well, 3 more times, so it's 23. Okay. Now, it'd be wonderful if 23 and 75,000 canceled out. Unfortunately, they do not. However, I can still go ahead and do the top math mentally. 2 times 75 would have been 150. Okay, but it's 20 times 75, so I'm going to put an extra 0 in there. And then I've got these last 3 zeros. So this is actually going to be a pretty big number. It's going to be 1,500,000 divided by 23. All right, and I actually am going to go ahead and use a calculator so I can get this video done for you quick. And I get, let's see, make sure I got the right number of zeros. I need 5 zeros. There we go, divided by 23. And sure enough, I get a population of 65,217.3. Well, we can't have 0.3 of a person, so we're going to round to the nearest whole number, and the population is going to be 65,217 people. Okay. Now, if I take that number and I figure out what 15% of that is, I should get about 9,783 people, and sure enough, if I add those in, that'll bring us up to the 75,000. All right? So, whether we're doing discounts or increases, really what you need to do to solve these problems, you need to read the questions carefully, and we need to convert them into the same kind of proportion and percent equations that we've dealt with all chapter long, okay? And then we need to carefully solve them. All right. Now I'm going to give you a choice of problems tomorrow, or Monday when we go over these in class, because it is a problem-solving lesson. So make sure that you review this prior to coming to class, and we'll just practice some of these in class. Okay, and then we'll start wrapping up the review to get ready for our test on Thursday. All right. Well, thank you for watching. I'm going to try to keep this under 9 minutes. So this is Mr. Gunn signing off. Enjoy the rest of your weekend. Goodbye.